Impact craters on planetary bodies are a testament to ancient celestial collisions. They have fascinated scientists for centuries, offering a glimpse into the violent history of our solar system. From the moon's dark, airless surface to the rugged terrain of Mars, impact craters are a common feature of planetary geology. But why are they so prevalent? And what can they tell us about the early universe? To understand the significance of impact craters, we must first consider the forces that shape our planetary bodies. Gravity, atmospheric pressure, and temperature all play a role in sculpting the surface of a planet or moon. However, impact craters are the result of an external force, a massive object hurtling through space at incredible speeds. Imagine a grain of sand containing an entire library. That's the scale of energy released during a planetary impact. The force of 1 billion nuclear bombs exploding simultaneously would be equivalent to the energy released by a large asteroid impact. But that's not the strangest part. The impact crater itself is often the result of a complex process involving multiple stages of deformation and erosion. Scientists have identified several distinct stages in the formation of an impact crater, each with its own unique characteristics and implications. The initial shockwave and deformation of the planetary surface, the excavation of the crater itself, and the subsequent erosion of the crater's rim are all critical components of the impact process. Wait until you hear what comes next. The impact crater can also provide valuable insights into the composition and structure of the planetary body itself. By analyzing the rocks and debris ejected during an impact, scientists can gain a deeper understanding of the planet's internal structure and geological history. And then something unexpected happened. The impact crater can also play a critical role in shaping the planet's climate and habitability. The ejecta from an impact can block sunlight, alter the planet's rotation, and even create conditions suitable for life to emerge. The impact crater on the Moon, for example, is thought to have been formed by a massive asteroid collision that occurred over 3.9 billion years ago. This event is believed to have deposited a layer of debris on the lunar surface, which would have provided a source of nutrients for early life forms. But how can we be certain of the crater's origins and history? To answer this question, scientists have developed a range of techniques for dating and analyzing the rocks and debris found in impact craters. Radiometric dating, geochemical analysis, and even the study of crater morphology are all used to reconstruct the history of an impact crater. By combining these approaches, scientists can build a detailed picture of the impact event and its aftermath. So what can we learn from impact craters? And why are they so important to our understanding of the universe? In short, impact craters offer a unique window into the history of our solar system, providing insights into the forces that shape the planets and moons we see today. They remind us that our planet is not unique, and that the universe is full of violent and transformative events that have shaped the course of history. And as we continue to explore and study the impact craters on our own planet and beyond, we may uncover even more secrets about the universe and our place within it. If you found this fascinating, subscribe for more incredible stories like this. Want more mind-blowing facts? Hit subscribe and join our journey of discovery. Thanks for watching. Join us next time for more engaging and informative content.